Yes, so over here we have the biology corner. I have some bacteria over here, bacteria and some fungi and some live insects. I have an insect over here and some millipedes. So we're going to visualize them, try to see them, study them using our eyes, using this magnifying lens, and also by the use of a microscope.
So you can observe the legs, the facial structure, the body. Yeah, it's pretty cool, sweet stuff. Okay, not sweet, you can't eat these guys, please. It's pretty cool stuff. Yeah.
Okay, we also have lenses, so you can tell them each the magnification of, for these containers at the lid they have a magnification, so it's not the same as how you can visualize it using your bare eyes. The magnification increases from this to the lens, the magnification increases to the, what is this?
Microscope.
A microscope, and then to the microscope to see how it looks like. So we'll start with the millipede under the microscope and place it on the stage. Oh my god, they are medium.
Their legs look like hands. If it's moving, I'm gonna kill it. I won't even do it.
So far this one is immobilized, so it can't move, but you can visualize its legs, its body. You can see it's segmented to its legs.
Yeah.
This is the anal part. So, and then next you can see I have a grasshopper as well over here. Let us study it and see it.
This is way too cool.
You know, I've never
Oh my
really
God.
cared about insects, but this is so
Uh-huh.
cool.
This brings
Look at it.
The eyes, its antennae. So it's fun and still you're learning.
Fact, I tried to put a grasshopper near my eye, but it was still alive, so it kicked my eye.
Definitely, because it is live. So for the live animals, and then next we'll view this. These are microorganisms. So these are macro organisms.
Micro is small.
Macro is big, micro is small. So for this, we have some aspergillus, several aspergillus. You have fusarium. You have trichoderma over here, and you also have penicillium, which is an antibiotic, and we also have some bacteria here. So we'll visualize them,
big words.
observe the colonies. The colonies is how they exist. A colony, I myself, if I am a bacteria, I myself is one colony. We together we are a colony of
Bacteria.
3 bacteria. So you can count how many bacteria are here
Yes.
and how many fungi are here.
Those
So
are
from
really
this-
fun guys.
Yes.
These guys must love to party.
Fun guys.
Can you
Wonder they're in
describe
groups.
this? This is a fungi. How do they eat? We said we studied it via our eyes and also through the microscope. So describe to them how this fungi appears, and also this is a bacteria. So you have a bacteria and a fungus.
So you can see that it's growing in patches, but some of it are spread out, and it also has a white lining if you look around it. And then it also has some white patches over here, so you can see the bacteria growth.
This is a
For
fungi.
this one,
Yeah,
Yes.
fun guys, man. Fun guys.
for this bacteria, you can see the striped pattern. It's like this. Most of the time it's done like this so that they can grow in colonies, but as you can see right over here, there are some that have decided that they want to do their own thing, and they went outside of the colonies, so they're not in like the gridded pattern.
Streaked
Okay,
bacteria.
good.
It's also really fun.
So from that, they've started them using their eyes, and then we can visualize them under the microscope and see how these colonies look like. Again, in a science class, use gloves. Please, if you touch them with your hands, and then try to eat something, you don't want to know what's gonna happen.
You're gonna burst open with microbial life.
Microbial overgrowth, and you'll get ill.
Honestly, I wouldn't put that in.
So
It looks like
you
a
can
snow
see the
in a forest.
it looks
Yeah.
snowy.
Minecraft biomes.
Yeah.
Minecraft biomes. Just goes from green. and
So how
lush
it
to white.
looks with, and this one looks like
A
Forest.
a forest, a spongish. You can also look at the growth of this side or this one.
It looks like a beachside forest.
That's so cool.
Honestly, it was
So
made for
where does this fungus get its food from?
Pigs.
Yes.
That pink stuff underneath.
What is it called?
Food.
It's full. It's called agar. So this is where I culture my fungus or my bacteria from. So it contains nutrients, everything that the fungus requires to grow. When the nutrients under here, you can see the pink background. So if it exhausts the nutrients, it stops the growth. As of now, you can see the growth has
Stopped.
yes. This was a fungus.
Really fun, guys.
And bacteria, and now over here we have bacteria. We can try to see its colonies. You see there are colony of 3.
Yeah.
So let us see these colonies. They
That's
exist in a
crazy.
colonies of this, nice. And then we have some for bacteria and fungus, some are nice, some are bad to us.
But you only hang out with the farmers.
Yeah.
You have both in your guts. Along your gut, you have them in your head. So, what causes ringworms? Your ask.
Fun guy.
Fungi.
Oh man, those guys.
What causes
Yeah.
what causes your gut to have? You're always told to take probiotic yogurt. So, which kind of bacteria that causes your gut? I mean the beneficial bacteria that is present in the probiotic yogurt.
Yeah. I don't know which one is present.
So you can see the colonies. They appear in streaks. And that is it. So
Right now here we're going to try and do something. We call it balancing of nails. Have you heard about that before?
No.
No, wait. Is that one where you balance a nail on top of nails?
On
Yeah,
top
yes.
of nails.
Like
Yeah.
you find the center of gravity, then you
Good. So you have an idea. We find the center of gravity of many mass of these nails on top of this one single nail. So if I were to give you a challenge, and then I say maybe I'll give you 8 nails and then you 8 nails. So and then I'll say I want 16 of those nails on top of this one single nail.
that is not possible.
That is not possible.
That
Do you
is
think
not
so?
No.
But
It is
science makes that possible.
I
Okay,
refute.
you say it's possible, right?
No.
It's not
You
possible.
have to prove it.
Well,
first.
we're going to prove it. So I'm just going to give you quickly at least 8 nails. So those are 3. How many are those? 4. Those are 8. And then we'll have 8. So 8 for you, 8 for you. And then what I want you to do is just don't play with them. So what I want you to do is just you might want to discuss in about 1 minute how you can balance all the 16 nails on top of this one. And as you discuss, you try to balance them so that you okay. You can start.
Triangle.
Huh?
Triangle.
So this is what you do. This is what you need to do. Now we have 16 nails here, and sometimes you're given work to do. And that's why I told you to do a group work. So I told you to discuss, right? And then when I tell you to discuss, I expect that you first discuss what the problem is and then find a solution to it, the quickest solution possible. So you form a group first, and then after forming a group, somebody will come, maybe I know English, and then somebody will say, maybe I know math, and then somebody will say, I have an idea about... Yes, that's why I told you had an idea. So see, if you could have built on that, then you had the perfect idea to make that. And then after arranging all of these things this way, so what we do is just to balance them alternately so that we can equal the mass on this other side to the mass on this other side, so that it weighs the same on either side. So after that, also probably that way, then last one this way, and then we'll just take this one to pin it all down, and then what we do is carry the rest of the thing this way and rest it on top of this one. So we're going to find the center of gravity of it and then just
Which that?
that's science. So you said it can't be done, but it can be done.
Guys,
It can be done.
stop.
You are using witchcraft.
No, I'm not using witchcraft. So we do say Nimao.
No. How? No.
See you, Chavi.
This is
Guys.
not possible.
It's possible.
What?
You use
no.
You can even.
must have used.
Okay, you can even
superglue.
destroy this, and then if you want to do it again, just do the same procedure.
So let's start like that. No, okay, fine, yeah.
Okay.
Then
Guys, this is all me. This
no, I walk through this.
So I'd love to give credit to both of you because we discussed while doing it, and then you managed to do it. So with us we have.
Then a slip on nails.
This works with the principle of center of gravity, so finding the center of gravity of objects. But then again, I am going to ask you to do just one thing. So we are going to start with this now.
Sharp point.
It's a sharp pointing nail, good. And what else?
And it will hurt if I touch it.
If you touch it. Okay, it might not hurt, but it might hurt if you touch it wrongly. So that is first safety. That's why we are so much concerned about safety. And another thing is we are trying to explain about the surface area of this, nail to the volume ratio that will be rested upon it. So that is, do you think you can sit on this one single nail?
Nope.
No, I think I can.
Please don't.
I think I can.
If you do,
Or I'll call Mo to try.
Who's more?
Mo is Maureen.
Maureen.
Do you think she can?
Maureen.
Do you think she can?
No.
That is because this one single nail exerts more pressure. Now, unlike when you sit on this one, so the pressure is distributed equally on this. It's spreaded equally. It's spreaded equally on top of this nail. So that when we put maybe 5 kg of mass on top of these nails, then that 5 kg is distributed equally on top of these nails that are in direct contact with the object. For example, I'll ask who to come and try. So I'll put it that way, and then I'll ask you to come and just try to have a seat. Now let me demonstrate first.
If I die.
Let me demonstrate first what you're going to do.
Do it.
Let me demonstrate. So first you're just going to come this way, then you're going to have your soft seat.
How much were you beaten by your
Now I
mother?
can even hang on it and I don't feel anything because the mass, my weight is distributed equally on the surface of the nails that are in direct contact with my body. Unlike when I could sit on that one single nail. So somebody's going to come and try. Okay?
What you said, comfy seat.
It's very comfy. It's a very, very comfy seat.
I mean,
Yeah,
it's
just have a
not
seat.
that
Trust yourself.
comfy.
Trust yourself.
I mean, it's not
Does it feel like
that
nails
comfy.
though?
But it doesn't feel like nails.
It does feel like nails. Really?
It doesn't feel like
And I
nails.
would want you to compare the comfiness or the comfortability with if you could have sat on this.
I couldn't sit on that.
You couldn't sit on that.
I can't sit on that.
Good. So maybe Caleb could try if you want to. It's comfortable though, right?
Yeah.
Good. And it doesn't come out as nails really. And that is the end of this. First, we have to stress on safety precautions. Now, before we do this, we first have to wash our hands, actually cold water. That is because water is a bad conductor of heat. Now, when you wash your hands, you're not going to feel the heat directly on the skin. Again, we have to be at a safer distance from one another when you're going to do the fire show, so that somebody doesn't catch the fire accidentally. Now I'm just going to make some bubbles here. So this is water and soap. And then after that, we are just going to scoop it, and somebody's going to light us up, and it's going to be thrilling and fun. Now, let's go. So then pass me the flame.
Yo,
Wow.
Bendy.
Oh my day!
Yo, my turn, my turn.
Oh.
My turn.
Oh.
Whoa. Then pass the flame.
Oh.
Wow.
I feel so
Again.
powerful.
Now, was that fun?
I feel powerful.
Can you do a smaller one?
Now,
I feel so powerful.
that's what students
You ask
normally
for
ask. Now, when you ask, can we do it again? Can you do it again? That's the
No,
fun
next.
part. And then just do this. Then you notice what's happening.
Oh.
Yeah.
Hi guys, for this experiment we need gloves.
We have chemical compounds, chemical components. We are testing for acids or bases. We need to determine which is an acid, which is a base. We have our suspect over here, potassium hydroxide. What is to determine potassium hydroxide is an acid or a base? We have our compound over here. We have our homemade indicator,
Good.
the purple cabbage.
Oh, so that's
So
what
far-
it is for. You know, honestly, when I saw it, I thought we were gonna be making a
No,
stew.
so the first thing is to crush the red or the purple cabbage
This
and
way.
extract its juice, and then dissolve all our suspect products using water.
Water.
And then we'll determine which is an acid or a base.
Now,
Yeah.
the fun part of this is we are going to observe the color changes in all the solutions we're going to have. So as we are going to dissolve them, and then we are going to first use our litmus paper. So we have litmus paper with us, this one, and then it's going to change color depending on whether the solution is a base or an acid. Okay? Now, after that, so this is called a litmus paper. Now, litmus paper is made from a fungi called lichen. Have you heard about lichen before?
Yeah.
So we have moss, we have lichens. So it's made basically by absorbing this paper into the juice extract of that lichen. Okay? So that lichen is an indicator of whether a solution is base or an acid. Okay? Good. And one thing we know with acids is some are corrosive, some are irritants. So let's take caution so that we don't touch them directly. Okay? And then one thing we know with bases is an example of a base is like a soap. Okay? So these are mild. Some are corrosive, some are mild. For example, we have one here like sodium hydroxide, which is not so good. And some doesn't smell so nice, so we just take caution so that we don't smell them directly. You can waft from a distance, okay? And some we are just going to smell them from a distance. So once you manage, it's okay. It's okay, don't worry.
This is so.
So the whole of that.
Oh no!
Thank you.
I spilled the
No, don't worry, don't worry. We're going to wipe it away. So, guys, this here is going to act as our indicator. So we're going to use red cabbage juice as our indicator. Now we're going to put it just right there, and then our kishungi and the rest. So these ones we are done with. We just put them somewhere there. And then now next, we are going to dissolve our samples. See? What did Sorry.
Did you see?
So next we are going to dissolve our samples with water, just a little, into all of those tins. Now after that, we are going to stir them so that we find a perfect solution. So if you're close to one that is solid, you can just stir it.
So get one and stir until it dissolves.
Now as we start, I want you to use your senses. For example, the visual senses, and then you can touch. For example, the ones with solid, you can touch them and you'll feel, because the water is cold, and while you continue to dissolve it, it gets warm. For example, we have this one here. I'm going to ask you to just stir it and feel. It's going to be a little bit.
Or this is potassium hydroxide.
That is
Just place your
potassium
finger
hydroxide, so you
over
can just
there.
touch it this way. You feel
It is
starting-
hot.
Yeah, it's starting to get
In a
warm.
chemical reaction, you either produce heat or a gas is evolved.
You rapscallion. You flimmy blubbers.
Okay,
So
so that way, dissolve it,
all.
dissolve it. Just stir it so that it dissolves. And one thing you're going to notice with some of this is that they look cloudy right now, but after everything is dissolved, they're going to be colorless, clear actually. Good. So,
What's that smell?
and
the sodium hydroxide.
maybe if the team might just want to feel it also. It's very hot. It's very hot. It's very hot right now, but we don't have heat, remember? So that is sodium hydroxide pellets when dissolved in water. So that is one fun part of it, because we didn't use heat, but some are already hot. Okay? Now, the second fun bit of it is we are just going to remove the spoons now. Bicarbonate, sodium bicarbonate. Now again, we are going to do one on hydrogen peroxide. So let me try. Then I just dip it down right there. Then what's the color when I remove it out? So it's a shade of red, right? It's a shade of red.
So it's
So
not
that's
kind of bad.
good. Then which one next?
We go for this one.
Starch solution. So we're going to try that and see. Just dip it inside there.
Is there one here that's so dangerous
Then
that you
when I
can't
remove
touch
it,
Starch, no change. So it's a
okay,
neutral.
so it's both neutral.
It's a neutral.
Is there any other we've not
Yes.
tried?
These three.
Which one?
Then we have
Have one.
vinegar,
It's an acid. Good.
acid,
And you see that color? Good.
red in
And then which
color.
one else?
We also have bicarbonate of soda.
Dip it in the bicarbonate of soda and then let's see.
Wait, can you just my Sprite?
That turned almost green.
Yeah.
Okay.
So today, I was wondering what do you put inside your body? So we have this soft drink over here that's been shaken up a bit. We want to see what it is.
Then you just take that and then dip it inside so that we see.
3, 2, 1, go. That's so.
And then just remove it outside so that we see. So that's a shade of
An acid.
because it contains an acid. It contains carbonic acid. Remember, when you open it, there is a fizz that's coming out. Guys, this is where the fun bit of it comes from. So this is what I'm going to do. I'm going to take my dropper. This is just a dropper. And I'm going to suck some little juice from this cabbage juice. And then I'm going to drop it inside our tin of sugar. So just that way, drops of it, and then we see what happens. So for example, when we add even more into that sugar solution, then nothing much is happening, right? Nothing much is happening because the color is the same. But then I'm going to ask you to try with the different solutions we have here. And so we are going to see. So first you start with this one. Now, baking. Okay, so 1, 2, 3, let's go. No, start with this one. Let's go this way.
Green.
Can you see? It's turning green. And then you wonder where green is coming from a colorless and a purple liquid.
This is crazy.
And then that,
This is just
which is color is it?
Pink.
It's pink. Okay, just add all of it.
All of it.
Good.
Good.
And I would
Next
ask you to
one.
add a little bit here so that we find. There. Good. see that green now?
Do not use that again. Do not use that chopper. Just when you're dropping the liquid, don't put it inside your
Don't immerse it inside the solution.
inside. Yeah.
Okay, so we do another one.
We throw this one.
We just put it inside the bottle.
Okay, then I take some.
Mhm.
Wait, let me take some.
Good. And then drop it inside here. This one. Then let's see the color change. Which color is that?
Yellow.
It's yellow. Now yellow from purple.
And that one's also
That is also pink. Good. Then we go to the next.
Wait. This other. Whoa.
Mm-hmm.
No, it's
Still, it's really yellow. Then there.
Yeah.
Caleb, what's the color there? Can you use it?
Why are all of these
Good.
turning
It's almost red.
red.
It's almost red.
And let's test this one.
Mhm.
Blue.
That's blue, right? Good.
Blue.
We are determining the color of the ring.
So we are going to arrange them in that order of the color maybe after that, so that we see which one is more
No,
base,
why
which one
not
is
blue?
more.
A color that's not pink. All of them have been pink. So nice.
So this is an experiment that you can do at home because some of the materials we've used here, it's just salt. Some readily available materials within your at home. So you can do it for fun, but still learning about acids and bases.
Green.
Good. So guys, we said if it's red, then if it's red or anywhere in the shade of red, then it's an acid. And if it's green or blue, then it's in the base side, okay? So we can arrange them in the order of bases or acids.
So wait, this one, let's so this one goes there.
Mhm.
This one goes there. Then this one's there.
Mhm.
Then wait, no.
Yes.
Then after green comes
Red or
this, no this.
Yeah, there's that.
Yes.
Then there's that.
Blue.
Good.
Did you put this one?
Yeah,
Yeah, we did. This one just.
we did that.
This is a shade of yellow.
So this one I think it comes.
Yeah.
I
think-
This one comes after.
Mm-hmm.
And from there, they go there. Nicely done.
And then we're not yet done. We have two here.
Oh yeah.
That one, then put
That-
this one on the
Mhm.
first.
No, wait. That one, no, yeah, that one's a green.
This looks like red.
Then that one's
That looks like red.
Yeah.
No red. The shades of red are on that other end.
Wait, let's put it
Good.
like this. Let's put it like this because that blue comes purple, and then you can go with the deep or red.
So right at the middle there is our indicator, okay? So an indicator we don't categorize it as a base or an acid. So we're going to remove it from the equation, okay? Good. So then we can say that substances on this other side are acids and substances on this other end are bases. But an example, sugar is kind of neutral. So sugar is a neutral solution. It's going to be there at the middle because before we go to, from our chart here, we have a chart. So it's from 1, 3, 5, 6, 7. And then 7 is neutral, like water. That is neutral. Now, up above 7, those are the bases, okay?
Yes.
For example, 8, 9, 10, 11, 12, 13, 14. And then towards the, up above the pH scale, so the further you go up above the pH scale, the more acid the substance, okay? For example, these ones are more acidic than this one. So we expect these ones to be in the ranges of about 1 to 3 in a pH scale. Then we expect this to be at about 5 or 6, okay? Yes.
Okay, for the next activity, I have these two sets of leaves. Do you love crisps?
Yeah.
Crackers, leaves, crisps, you really?
Yeah, I like them.
I want you to make a clips of this leaf and a clips of this leaf, and you have a balloon. I want that balloon to fit this pocket of mine over here.
What?
Yeah.
Just reflect it.
No, I want it to fit in less than 2
Okay, so with
minutes.
the air inside, find
Yeah.
a way so that it can fit inside the
It
pocket.
fits my
And don't
pocket
deflate it. So it should
with
still
5
have the
minutes,
air.
and how this leaf will look like the clips that you take, the ones that you like, within less than 2 minutes.
2 minutes.
Yeah. both of them. This should fit in my pocket, and this leaf should be completely dry. When I crush it, I can crush it like if it's.
So what do you think we need to do so that this is dry as grapes? Then I can fit so that I can fit that balloon.
I know how to fit this.
So how do we do?
So I think
Ooh. Yes, that's one method of doing it. That's one method of doing it. But we don't want it to pass. So we still want the air inside so that when I travel with it, maybe let's say from here to Nairobi, the CBD, it still has that air inside.
you need hot water.
You need hot water. What will I do with hot water?
No, hot water will expand it. Cold water, I think, deflates it.
Cold water deflates it, right?
Yeah.
It doesn't really.
I
cold,
still need
just-
the capacity of air inside to be constant all the way.
So do you think it deflates it really?
No.
Uh-huh.
I don't know how.
Have you studied about condensation, evaporation?
Yeah.
I think I know.
You know something about
Yeah. Okay. So maybe when we have the balloon here,
Don't burst
when you,
wine.
I'm not busting yours. Plus, you can just say this another. So when we dip it into the whatever, when we put it in the fridge, so the rubber particles contract at the same time as the air particles inside, reducing in size, or easier way to say it, they are coming together.
Good.
So that reduces the size of the balloon. But the only way we could do that is with
Liquid nitrogen.
Perfect. So now we are going to use liquid nitrogen.
Liquid
So
nitrogen.
Same. Now we're going to check this. Just put it right up about here.
Let us go.
And then
I book
the next
dipping.
thing we are going to do
Wait.
is
Let me blow mine as well.
the next thing we are going to do is put these leaves inside there. Okay? So you can see they are still
Yes.
green and soft and right? Then we want them to come out.
We need to dip one at a
So
time.
what we're going to do is
Ouch.
we're going to raise just a can of liquid nitrogen.
Wow.
So we're going to open it. How do you think rain forms?
When clouds come together, when
Air
How do-
particle, water particles.
when condensated water particles participate and come together.
Participate and condense.
So-
I do not know.
So we can
What do you think happens?
So the water comes closer together.
In line of temperature. In line of temperature.
The water cools closer together because of the heat. It goes into the sky and starts to cool. And then when all the water particles have cooled, they come together, but they are not yet water. Then once they became water, like the magic you drink, they are prepared to be floating in the sky and they fall.
So good. This is how it happens. You see, most of the times, daytime when there is too much heat. Now, the heat hits that water. Maybe it could be a lake or a river or a pond or a swimming pool. Then now the water starts forming, right? Then as it goes high up above the sky, it meets cold air, right?
Yeah.
Then that cold air condenses that. It condenses the vapor.
Yeah.
The water vapor.
Yes, the water vapor. Then it becomes cool, right?
Yes.
Now, when temperature rises again, it
False.
forms now a cloud in terms of now that cold air or that cold water vapor that is hanging up above the sky, it gets heated again
Yeah.
to form things like cloud, right?
Yes.
Yeah.
Then those clouds will be too heavy or too saturated, so too heavy, then they fall back again as rain. So we're going to try that and see what
So
happens
place the balloon inside here.
with hot water. Okay?
The balloon is
We have hot water already here
Wait.
with us.
Mine first.
Let me just add it first, then we dip it.
Oh.
Yeah. So let the leaves there. Just remove the leaves. So I'm going to add
Ooh, liquid nitrogen.
nitrogen. Now
You
let's see.
can't.
You know you can touch the nitrogen for like 5 seconds.
Oh.
Let's see.
Burns!
It burns or
Okay.
it's cold.
So that way. Now, after pouring it in, you can try and see.
It's
Just
mega
put this
cool.
inside, put that inside, put your balloon inside. Put your balloon inside. Just give it a-
This is so cool.
What does it
Oh,
look
it's
like?
cool.
It's boiling.
It looks like it's boiling.
Yeah.
Because it actually is. So remember, at that high temperature, it was cool. But now, because the room temperature is way
Hotter than.
hotter than the liquid nitrogen, now it's boiling.
Yeah.
Yes? And you can notice from inside here that the balloons have already started decreasing in size, for example this
Yeah.
one, but it still has the air inside.
Yeah.
Okay?
That's so cool.
Then you can also see this is part of the leaf that was dry.
And they are
It's
crispy.
now dry, they are crispy.
Can you eat these?
Yeah, there are some ones here. Like a glass, right?
Yeah.
So we are going to,
This
Yo,
is
these are
cool.
like the movie.
This is good. Yeah, these are
I'm
like.
going to just spread these
Ah,
balloons
trees
here.
Italians.
Then we are going to see.
Yeah. Oh, this is so cool.
Just wait,
And cool.
it's very cold.
Yo.
Wait, I'm holding liquid
It's very cold. We need
nitrogen.
to find something to
No,
press
it's
it down with.
Nitrogen vapor.
It's very cold. So
And it's
Take
boiling, but it's boiling.
it's very cold. Now
The
suddenly,
outside is.
You can show them.
yeah.
Ice formed on my
So
hands. Ice formed on my hands. Look.
That's so
please be careful. Be careful. You don't touch it directly.
Oh, ice is forming.
Yo.
Let's try to release.
What?
Oh! Oh!
Just wait.
Yo, it's expanding. Wait, look.
Oh, it's expanding.
I mean,
Sorry for that. Now, this is what we're going to do next.
Don't hold it. Put it down. Don't stop.
yo, it's like a bomb.
This is what we're going to do next. So keep watch. Don't get your hands. Remember safety procedure. Safety
Oh, I'm holding
procedure.
there.
So we have a jug of warm water.
This is so cool.
I still can't believe.
Jug of
Yo,
warm water.
my balloon.
This is so cool.
Now let's watch.
But
Now
I
we
was
do a countdown of 5. We
Yes.
do a countdown of 5. So we go.
5, 4,
3, 2, 1. Oh! Yeah, it's so cool.
I want.
I want
I'm
some.
taking it.
I'll take it. Let's pack it. I'll pack it. This is so cool. Oh, nice.
Somebody must have picked it up and put it in his pocket.
Ah,
Yo,
this is so cool.
it feels
And it
so-
smells like air. I mean, it doesn't smell like anything. Wow.
It
Ooh,
smells like
look at this.
air.
You can like literally craft it.
So how was that?
Let me try.
Oh, this is too cool. Can you please do it again?
Yeah,
Please.
One more game.
Now,
Please.
and what can you notice? in them?
They both have
They are both.
holes, but they're not.
They have
What
like
are
mesh
they?
wire.
Mesh
Yeah,
wires.
mesh,
So
yes.
it's kind of a net, right?
Yes.
But do you think you can carry water with a net?
Yes.
We can.
I think
Yes.
we can.
Yes, you can.
How can we do that?
Okay. So you put it in the glass,
Mhm.
then you put like this.
Mhm.
Once you let go, the pressure inside will already be there.
Good. So we are going to try that.
Okay.
Okay. So I'm going to give you water, just right here, and I want them to notice. So just leave a space so that they can see. That way. So it allows water in, right?
Yeah.
Then I'm also going to give you some through that net,
Yours looks like it will be
and then just do it there on top of the table. So 3, 2, 1,
Wait.
flip. Flip. Then how do you do so that you have
Oh, mine fell. Oh. That's so cool.
good. So let me help you doing it with this.
Those
So
are
we just
wider.
put this
That was
water
wider.
inside that way.
Can I try?
Then you just cover. Okay, you can try.
Yeah, it's not working.
It's not working.
Let's try this
So let
one
me
again.
let me try with this and then let's see. Just one last time so
Wait,
that we don't
then-
waste time.
Can you finish with this one?
Submit with this.
mosquito net? Mosquitoes can't breathe. So what
So
about-
this is what we're doing. Cover it with your hands this way,
It's warm again.
then up that way, then 1, 2, 3.
No way.
Yeah. So that. So
think
it's
you just
possible
have a
with
skill.
every type of net. It doesn't really matter which net you're using. Okay.
Bro, you can't say that
So,
on the podcast, man. Can you
That
like,
marks the
oh,
end of our fantastic reading lesson.
That's
Okay.
Can we do this thing again?
Yep.